Hi, good morning. Today I am going to continue the explanation of alternating voltage and current. In the last session, we took the voltage and the current of resistor, pure inductive coil, and a capacitor. And we concluded that voltage U and I passing through resistor R are in phase. يعني الفاي equal to 0. Also, we studied that U leads I by pi over 2 for pure inductive coil. And U lags I by pi over 2 for a capacitor. Okay. Also, in the previous session, I gave application for you and I case of a resistor and the pure inductive coil and a capacitor. But at that time, all my work was theoretically. Now I am going to take another example as an application also for the case of the capacitor. But you will see in this problem experimental study, how to use the experimental study as an application, and how also within the same problem you will use the theoretical study. This exercise or application says determination of the capacitance of a capacitor in an RC circuit. We intend to determine the capacitance of a capacitor through two separate experiments using the following circuit. This is the circuit that we are going to use to solve the problem. It says across the terminals A and B of a function generator, low frequency generator, are connected in series a resistor of resistance R equal 100 ohm and a capacitance of capacitance C. An oscilloscope allows us to displace voltage UAM across a channel Y1. So channel Y1 measures UAM. This is UAM. And to display the voltage UAM on channel Y1 across the resistor, and to display voltage UMB on a channel Y2 across the capacitor. The invert bottom of channel Y2 is pulled so as to displace voltage UMB, which means that channel Y2 reads voltage UBM. But then we press the invert button so that it reads UMB. This is UMB. Why we should press the invert button? I explained this previously. You should know why. The answer is that you need to press it so that voltage UAM and UMB must have same direction, and here they have same direction. Now, عم بيقول the oscilloscope has the adjustment in both experiments. You have time base 2 millisecond per division, vertical sensitivity 2 volt per division. عم بيقول the horizontal middle line corresponds to 0. The voltages here are observed on the screen of the oscilloscope, and he said that the horizontal middle line corresponds to 0. What does this mean? This means that the middle of the screen, this line which is at the middle of the screen, represents voltage 0. So that above this line, the voltage is positive, and below this line, the voltage is negative. So I am going to write the given you have here. فإذا exercise okay. So the given is R equal 100 ohm. We want to determine C. Also, a time base, يعني SH equal till 2 millisecond per division, and SV 2 volt per division. Okay, experiment A, first experiment, part A. The low frequency generator delivers a square signal. So now, in this part A, the low frequency generator delivers a square signal like this. And as you know, what is the square signal? The square signal has this form, as we explained. U for 0 t over 2 and 0 for t over 2 and t, where the voltage here مبينة والله صغيرة ها. This is UAM UAB. This is the square voltage. عم بيقول what does the low frequency generator delivers a square signal. This is the square signal. On the screen of the oscilloscope, we obtain the oscillograms of figure 2. These are the oscillograms of figure 2, and you have here 4 waveforms, A, B, C, D. He is asking, what does each of the curves A, B, C, and D represent? Okay, let's look at A. As you see, A, the voltage is increasing from 0 till it becomes maximum and constant. What does this voltage represent? What does this graph represent? In order to answer this question, you should know which physical concept you should use, and I have explained it previously. You should think about charging and discharging of the capacitor, since you have here square voltage. And as you know, in the square voltage, in the first half period, the voltage is constant. It acts like this. And so the capacitor will be connected to a DC voltage, so charging of the capacitor takes place. In the second half period, the voltage of the low frequency generator will be 0, and the low frequency generator acts as a connection wire, so the capacitor will discharge. So you should know these concepts in order to answer the question here. Otherwise, you don't know how to answer it. So A, as you see, A, the voltage is increasing from 0 to constant value. This is the case of what? This is the case of a charging of the capacitor. When connected to a DC voltage, we know that the voltage of the capacitor increases from 0 to maximum value, which is equal to the voltage of the battery. Let's look at C at the same time. C, when the voltage of the capacitor increases from 0 to E, at the same time the voltage of the resistor decreases from E to 0. Why? Because E, if this is E, E is equal UAM plus UMB, which is constant. So as UM increases, UMB decreases by the same value, so that their sum stays constant. So we deduce that A with C represents respectively the voltages across the voltages, the UMB of the capacitor and the voltage UAM of the resistor. Now B and D. B, this represents the discharging of the capacitor. These figures represent the case when the capacitor discharges. Why? Because in this case, don't forget, this is the square voltage, like this. This is E, this is voltage UAB. ID, UAB, IDT. So, in the second half period, the voltage is 0, and the capacitor discharges. It acts like a connection wire, and the capacitor discharges. So, the voltage of UC, the voltage UC of the capacitor C during discharging, you know that it decreases from the maximum value it gets during charging, which is E, to 0 till it becomes totally discharged. So B represents the voltage UMB, which is UC, during discharging of the capacitor. And D represent voltage UAM, which is equal UR, voltage UR, during discharging of C. Also, why? How do you know this? Since it is discharging, you know that E is equal to 0. E is 0 because there is no voltage anymore, so that UAM plus UMB equal to 0, which means that UAM is equal minus UMB. Yani this means UAM and UMB have equal values but opposite signs. And since UAM decreases, UMB increases. And UAM decreases from E to 0, so UMB increases from minus E to 0. Okay, this is justification You should know, but you shouldn't threaten, because the question here doesn't need justification. And بيقول what does each of the curves represent? So I will write the answer here. A1, A represents voltage. Represents voltage. U and B during charging of C. Charging of C. C, part C, represents voltage UAM during charging of C, and the B represents voltage UMB during discharging of C. Discharging of C. And the last one, D, represents voltage UAM during discharging of C. Okay, this was part 1. Part 2, عم بيقول, part 2 says determine using the oscillograms the minimum and the maximum values of the voltage delivered by the generator. So he wants the minimum value of the low frequency generator, UAB minimum, and the maximum value of the low frequency generator. So we want to find UAB minimum and UAB maximum. As we said here, look at the voltage of the low frequency generator. It has maximum value E and minimum value 0. So the minimum value UAB minimum is equal to 0. Type. How to find the maximum value? UAB maximum. How to find it? As we said, if you take the voltage of A, which represent the voltage of UC during charging, the voltage increases from 0 to maximum value, which is E. So E represents here 3 divisions, 1, 2, 3. 3 divisions times SV, which is 2, gives you 6 volts. So the maximum value is 6 volt, which is also the voltage of the low frequency generator. Part 3, it says, give the expression of the time constant tau of the RC series circuit. So the time expression, you want the expression, and you know that the expression is only R times C. And determine its approximate value using the oscillograms, knowing that the voltage UMB attains 63 of its maximum value. Okay, to determine tau, he is saying that the voltage UMB attains 63% of its maximum value during the charging after time tau. So عم بيقول at t equal tau, UMB is equal 63% of its maximum value اللي هي UMB maximum. Okay. Since he is saying at t equal tau UMB 63 during the charging phase, this means that to determine tau, I should take graph A. And as you see here, you have a maximum value 3 divisions. So we can write at t equal tau, UMB gives 0.63 times 3. And you get here 1.89 division, اللي هي approximately 1.9 division. So to determine tau, I should move around 1.2 divisions. This is 1.9 division. Yani this means at this point I draw a horizontal line to intersect with this, then I make orthogonal projection in order to get tau. Since this is the t-axis, don't forget, and this is the u-axis. So tau represent, this is tau, this is tau. I have used the definition of tau. So tau represents to 1 division. Tau represents to 1 division. To change it to time, I should multiply by SH 1 times 2 milliseconds. You get tau equal 2 times 10 power minus 3 seconds. Then he says, deduce the value of C. So I can deduce now the value of C. Because tau is equal RC, then C is equal tau over R. It gives 2 times 10 power minus 3 over 100, gives me 2 times 10 power minus 5 farad. Okay. This was experiment A, and the importance of this experiment, it is a revision of the previous chapter. When R and C it is a revision of the previous chapter where you have R and C connected to square voltage. Okay? Now in part B, experiment B, we are going to find C by the low frequency generator delivers now alternating sinusoidal voltage of a frequency F. So instead of using a square voltage, we are going to use, so part A, we get 2 times 10 minus 3 seconds, and C equal 2 times 10 minus 5 farad. In a part B, the low frequency generator, you still have the same shape, but I replace the low frequency generator by a square voltage. Okay, Heidi, Y1, this is Y2, MA, MB, plus the invert. So, now I replace this by alternating sinusoidal voltage. So in this part you should concentrate on the voltage and current delivered by sinusoidal, by alternating voltage or sinusoidal alternating voltage. Now, all you have the low frequency generator delivers alternating voltage of frequency f, and we adjust f so that to obtain curves of figure 3. He says, 1, the oscillogram 2 represent voltage UMB. The question is, 2 represents UMB. Why? This is the question. As we said, you have here case of R and C connected in series. And you know that in this case, we said that useless C lags R, lags I or UR. And you see here that 1 leads to, this means that 2 lags 1. This means that the graph 2 represents voltage UMB or voltage UC. Okay. We know the voltage across C lags UR or I, and waveform 2 lags 1. This implies 2 represents voltage UMB, which is equal UC. Okay. Type part 2, determine using figure 3. Look at 3. Determine using figure 3 the period of the signal delivered by the low frequency generator. So 2A, he wants the period. How to find the period? The period of the 2 graphs is the same. Okay? So I can choose any one to find the period. If you take waveform 1 and you start from point 0 here, you have this point 0 and decreasing. Move your hand with the curve. You get this point 0 and increasing. This doesn't represent a period. Let's continue. You will reach this point, and here 0 decreasing. So this represents the period. 0 decreasing to 0 decreasing. Okay? Or, if you like, you can take this maximum and the consecutive maximum. Also, this is period. So the period, if I count here 1, 2, 3, 4, 5, so the period represents to 5 division. 5 division, to change it to time, I should multiply by SH, which is 2. So you get 10 millisecond times 10 power minus 3 second, you get 0.01 second. This is the period. Now he wants the part B, says the phase difference between the voltage UMB and the current I. So part B, he wants the phase difference between the 2 graphs. What is the phase difference? The phase difference, it is the difference between the two graphs. Okay? Now, difference between the two graphs represent the phase difference. So this is phi we want to find. These are two consecutive zeros and the graphs are decreasing, or two consecutive zeros, the graphs increasing, or this is also phi. Here, this is also phi, two consecutive maximums or two consecutive minimums. The best reading, always you should look carefully and choose the best reading. I think that this phi is the best reading. It is about 1.25 division. So phi corresponds to 1.25 division, but phi is in radians. So I use this formula to change phi to radian. So you get 2 pi times 1.25 and a capital D, which is the period of the division, which is the divisions of the period, is 5 over 5. So you get 2.5 pi over 5 gives you pi over 2. And you can check that your work is correct. How? Because from the explanation, we studied that U lags I by pi over 2 for a capacitor. And in this case, you have voltage across the capacitor and the current. So the phase difference between them should be pi over 2. And this is what do we get. This means that my work is correct. C, he wants the maximum values of the voltage across the capacitor and of the current in the circuit. So part C, he wants the maximum voltage across the capacitor. Yani he wants U maximum of UMB, and he wants I maximum. Okay? Right. U maximum, what is U maximum of UMB? Number 2, we said that number 2 corresponds to UMB. So maximum is from here to here. This is the amplitude. Ideal U maximum of UMB. As you see here, it consists of 3.1 divisions. So I write UMB is equal 3 times 3.1 times 2, which is the SV, so you get 6.2 volt. How to find IM? We said that IM cannot be calculated directly. It is calculated from the voltage of UR. And the amplitude or the maximum voltage of UR 1, 2, 3, 4 is 4. So UR maximum or UAM maximum gives me 4 times 2, 8 volt. UAM is equal RIM. So IM is equal UAM over R, gives you 8 over 100, gives you 0.08 ampere. Okay. The last part, which is part C, part C, the voltage across the capacitor is given by UMB. So UMB is equal UM cosine omega t. Determine the expression of the current I as a function of time and deduce C. He wants the expression I and deduce C. If you look at the voltage here, you notice that phi is 0, which means that UMB is given as a reference. So the expression of I is similar to expression of UMB, but with the phase difference. يعني I write omega t plus phi. To find the expression of I should find Im, omega and phi. I calculated it, it is given. So I need omega and phi. As you know, omega 2 pi over t, يعني 2 pi over 0.01 gives you 200 pi radian per second. Phi, what about phi? If you look at that, the graphs, we said that U2 or voltage UMB lags I. Okay? UMB lags I by pi over 2. But in this case, my reference is UMB. So I want to find I relative to UMB. So we write I leads UMB by pi over 2. يعني this implies phi is equal plus pi over 2 radian. So the expression of I becomes 0.08 cosine الأوميجا 200 pi t plus pi over 2. Don't forget the unit, t in second, I in ampere. Now, how to find C? C, you have relation between I and UC. UC is given, and I find I. So what is the relation between them? We studied that I is equal dq over dt, and dq is equal cuc or cumb. Substitute in the formula. يعني this means I want to differentiate q. You get here I equal c dumb على dt. Substitute, you get I equal c derivative constant derivative للcosine minus sine omega t times omega. يعني this implies I equal minus c omega sine omega t. If you look here, what is the maximum value of Im? I is maximum when the sine is -1. Okay? I is maximum when sine omega t is minimum equal to -1. This implies I maximum equal C omega UM. يعني this implies C equal IM over omega UM gives you 0.08 over الأوميجا 200 pi, and the UM, it is UM of the voltage of the capacitor, with 6.2, and you get the answer you get here 2.05 times 10 power minus 5 farad, which is 2 times 10 power minus farad, which is the one we obtained from experiment A. Okay?